Hello and welcome to Algebra 2. This is a video over section 6, which is called Composition of Functions. And before we get started, when we talk about a composition of functions, what I like to think about is the movie Inception, okay? So I think of Inception, all right? And the reason why Inception is because in the movie Inception, and this is a minor spoiler alert, but this is where they do dreams within dreams, okay? It's a very good movie, a Christopher Nolan movie, Dreams Within Dreams. So, the premise of the movie is that you can control things and get information through dreams. And so what they do is they go into these dreams, but then they go into dreams within dreams and all that. So when we talk about compositions of functions, all right, the reason why I think of Inception is because when we talk about these compositions, these are functions within functions. Okay? Functions within functions, which I like to call incepted functions. Okay? So functions within functions, dreams within dreams. Okay. So what you have here, we want to be able to write an expression for the composition of the functions, find the domain of the composition of functions, and then evaluate the composition of functions. So what you have here is you have multiple functions. You have functions within other functions. So what happens is that you have this one function here. You have your input, which is your x value. Okay, that's your x value. And then you get a y value, okay, out of that. Okay, when you plug in your x value, the operation happens, you get your y value. Then what happens is that your output, the y value of your original function, then becomes the input of your new function, and then you get another output. Okay, so that's kind of the idea. And so then, you have this other graphic here, and it says, we evaluate the function f, we take that y value from function f, plug it into function g, evaluate that, and get a new y value, okay? So a composition of functions is applying one function after another, okay? This new function is called a composite function, okay? A function within a function. So, normally what you see here, this is your standard notation for a composite function. Where, when you had a function f, okay, what was inside the parentheses was your x value. Well, what we have here is that we take the y value of our function g and then plug it into f. So it's not, we can talk about the notation forever and ever and ever, but it's best if we just kind of jump in and do some problems and kind of talk about it. So, let's just quickly answer a couple of these questions. It says another way to write g of h of x is, and we would write it like this. We would say let me write it a little bit bigger. g(OH) of x would be another way to write that, okay? And it says, in this composite function g of f of x, which function do you evaluate first? And you'd want to evaluate the inside function first. Okay, and that would be your function f. Okay, but let's go ahead and take a look at a real example here to kind of help us understand what exactly it is that we're doing. And so on this, you're given that you have a function f of x is equal to x minus 7, and then g of x, which is equal to x squared. So what it's asking us to do, it wants us to find all these different values. It wants us to find g of f of 4, f of g of 4, and then g of f of negative 1, and then f of g of negative 1. Okay, so what I would want to do here is if I wanted to find g of f of 4, the first thing I want to do is I want to evaluate my function f. Okay, so I want to find f of 4. So if I found f of 4, then that means that I'm looking at this function, I'm plugging in 4 in for x and seeing what we get for a y value. So here I would do 4 minus 7. So f of 4 would just give me negative 3. Okay, so now what I've done is I have evaluated that function f at x equals 4 and I get negative 3. What I need to do now is take this negative 3 and plug it into my function g. okay? Because remember what you have here. You have g of f of 4. So we have to evaluate the function f at x equals 4 first, see what that is, and then we evaluate g at that new value. So what we get here, instead of us writing g of f of 4, because f of 4 is equal to 3, negative 3, now I'm really just finding g of negative 3, okay? And so as a result, we get that this is going to be negative 3 squared, which gives us positive 9, and that's our answer, okay? So let's go ahead and let's take a look at this other one down here. It says find f of g of 4. So the first thing that I want to do is calculate g of 4, okay? And so if I do g of 4, then I'm just taking my, here's my function g, which is x squared. So I'm going to plug 4 in for x, and so I just get 4 squared. So we end up getting that g of 4 is equal to positive 16, okay? Now, it wants me to evaluate f of g of 4. Well, g of 4 was equal to 16. So right now what this becomes, all right, the whole thing I'm doing is I'm taking 16 now, my new y value, and I'm plugging it into my function f. So therefore I get this. I get f of 16, okay, which is just going to be 16 minus 7. Now I'm plugging it into this function here. And then that's going to give me, what is that, positive 9? Is it a coincidence that we get the same thing? I think so. Yeah, you're not always going to get the same thing depending on these composite functions, but we end up getting the same answer on those, which is kind of a coincidence. But usually it's not always going to happen. So, all right, let's take a look at another one. Okay, it wants us to find g of f of negative 1. So the first thing I want to do is evaluate my inside function first. Okay, so I have f of negative 1, and that's just going to give me negative 1 minus 7, which is going to give me negative 8. Okay, is that right? Yeah, negative 1 minus 7 is negative 8. Okay, so this is what f of negative 1 is equal to, okay? Now, I'm going to take this value here of negative 8, and I'm going to plug it into my function g. So now what I get, what I'm going to evaluate, is g of negative 8. Okay, and then that's just going to give me negative 8 quantity squared, which is going to give me positive 64, and this is the answer that we're looking for. Okay, so that's it. All right, evaluate your function f, okay, get a y value, and then plug that new y value into your function g and evaluate. All right, so now on the next one, it says find f of g of negative 1. So let's first evaluate g of negative 1, okay? And that's just going to give me negative 1 quantity squared, which is just going to give me just positive 1, okay? So now I'm going to take this value and plug it into my function f, okay? I'm just going to plug it in here. So then the new problem is asking me to find, well, what's f of positive 1? And that's just going to give me 1 minus 7, which gives me a value of negative 6, okay? And that's our answer. So, that's all we're doing, okay? Again, we evaluate the inside function first, and then we plug in that value into the y value. Okay, evaluate your inside function first, okay? We did all that in all these examples. Take that new y value and plug it into the outside function, of the other function, and then evaluate, all right? So let's go ahead and let's take a look here. And on this, you have these same functions, and it's going, okay, well, let's write an actual rule for this. Let's get a function out of this. So when it says f of g of x, that means that we're doing f of g of x, okay? And what I'm going to do is kind of show you guys how I think about this. If I'm trying to figure out a composite function here, and like an actual function, what I do is I'm going to take my function g, okay, here, specifically the x squared, and I'm going to plug that into the x value of my other function, okay? So notice that, here's what we get, okay? And so if I wanted to find f of g of x, then what I'm going to get is I'm going to, take this x squared here, plug it in for x, and that's going to give me x squared and then minus 7. All right, now let's go ahead and let's do the other one. Let's do g of f of x. So let's rewrite this as g of f of x. And it's going to be the opposite. Okay, my input is my function f of x, and I'm going to take that function here, and I'm going to plug that function into my function g, okay, for x, all right? So as a result, if I were to find g of f of x, then that would give me the quantity x minus 7 squared, okay? And that's all you're doing, all right? And let's kind of talk about this for a second. I know this is kind of, very kind of confusing, and, depending on what you're doing, it can be a little tricky to figure out. But, here's what we know. We know that f of x is equal to x minus 7, and we know that g of x is equal to x squared, all right? Well, let's just think about what it means to have a function. And you guys are good at this. You guys are good at saying, okay, here's my function f of x. If I found f of, say, 7, you just plug in 7 for x and evaluate, and you get 0, okay? Well, if you do something like this where you say, okay, well, what's f of x squared, okay, where your input is another function, not necessarily a number, then what you would do is you would just plug that function into your variable that you had in your original function, okay, which is just x squared minus 7. All right, and think of it like this. All right, what would you do if you had, say, f of smiley face? Okay, then you would plug smiley face in for x, and then minus 7, and that's all you're doing. Okay, and hopefully you see that, and that's a part about functions is just reading it and knowing what it says. But what I want you to see mainly is this: is where you have. Say, if f of x is your variable, then that's what you find in your function, okay? Now, it's defined like that, so if you plug in, say, another function x squared, then that's what you plug in for x, is x squared. Again, if you have, like, say, f of smiley face, then you just plug in smiley face, all right? And I want you to notice, look at all three of these different functions, okay? And I'm going to ask you, what is the difference between them? And there really isn't any difference. It depends on what you're plugging into that function, okay? If it's an x, then there's an x. If there's x squared, then you plug in an x squared. If you have f of smiley face, you plug in a smiley face, okay? And, the same thing goes with this other function g, okay? If you wanted to find g of, say, 7, you guys know to just plug in 7, the number, okay? And that's going to give you, say, 49. However, let's say that you wanted to plug in, g of x minus 7, okay? Plugging in that other function, and all you would do is just plug in that function, x minus 7, quantity squared, okay? Let's say you wanted to find g of smiley face, okay? If you did that, then you would just take the smiley face and you'd square it. Okay, and that's what we're doing, okay? Instead of just plugging in numbers, we're plugging in other functions, and then we're evaluating. So there's a couple different ways to do that, but I wanted to kind of show you that just so we weren't too crazy, going too nuts about it. All right, so here's what we've got. Let's take a look at this next one. It says, given that you have a function f of x is equal to x minus 7, and then another function h of x, which is equal to 2x plus 3, it wants us to write the rule for h of f of x. So here's what I've got. If I wanted to do h of f of x, then really that's, here's my function f, okay? I'm going to take this entire function, oh no, wait, other way around. Then I would take this, all right, here's my function h, my outside function. Okay, I would take my function f and plug that into the x value of my other equation, okay? So that's what I'm doing. Let me kind of write this out so it kind of hopefully makes sense. But if I want to do h of f of x, well, let's rewrite f of x. Let's rewrite this as h of f of x is just x minus 7, okay? And so, we have this function h that's defined, 2x plus 3, but if I wanted to write h of x minus 7, then that's just going to be 2 times the quantity, x minus 7, and then plus 3. So notice, here that you have this function h, and then you have this function h of x minus 7. The only difference is that your input has changed. Okay, here it was an x, and then you put an x there. Here, your input was x minus 7, so you replaced and put x minus 7 as that input. Okay, so then we can evaluate this, and we can distribute the 2, and that's going to give us 2x minus 14 plus 3, and therefore we get 2x, what is that, minus 11? And that is our new function that we get, and that is this function up here. Okay, so, all right, let's take a look at the next question. Then it says, okay, given the same functions, f and h, what would be f of h of x? So this is the one where I'm going to take 2x plus 3, plug that into the x value of my other function. So if I write this out, f of h of x, okay, then that's really me saying what's f of 2x plus 3, okay? Remember, h of x is equal to 2x plus 3. So then I take my look at my function and I go, okay, well, f of x is just x minus 7. I'm going to plug in 2x plus 3 into that. And so that's just going to give us 2x plus 3, that quantity, minus 7. All right. So that's just going to give me 2x. 3 minus 7 is going to give me negative 4. So 2x minus 4, and it is this one right there. Okay. So pretty standard stuff. You just got to get used to it and do all that. So, okay, so then on this one, okay, and there's a couple different ways to do this. It kind of depends on what you guys want to do. First thing I would do, when you see this FOG of negative 2, let's rewrite this. I always got confused with this, but if you rewrite this and say this is f of g of negative 2, okay, and you have this function f and you have this function g. Now you can do this a couple different ways. You can do it by first evaluating g of negative 2 and then plugging that value into your other function f. So we can do it that way. Let's start off with that first. So let's find g of negative 2. And, just given my function g, I'm going to plug in negative 2. I get negative 2 over 2, which gives us a value of negative 1. So g of negative 2 is equal to negative 1. Now I take this value here, and I plug negative 1 into my function f, okay? So then the next step is for me to go, okay, well, what's f of negative 1, all right? Well, let's look at that function, which is 6x plus 1. And so you get 6 times negative 1 plus 7, which gives you negative 6 plus 7, which gives you, what is that, positive 1? And that's your answer, okay? And that's what we're looking for, all right? But let's look at it another way. Let's look at it as, as a composite function, and let's rewrite this function. So, let's just look at it like this. Let's go, okay, well, what's f of g of x, okay? And then we'll plug in negative 2 into that. And so then you get this. Then we're going to take the actual function, which is x over 2, and we're going to plug it into the x value of my other function f. So therefore, we get f, so let me rewrite this. This is going to be f of x over 2, okay, which is going to be 6 times x over 2. And then, what was it, minus 7? No, plus 7. Then it was going to be plus 7. Whoops. Plus 7. Okay, so I have this new function, and what I want to do is I want to plug in negative 2. So I'm going to do f of g of negative 2, okay, which is equal to this new function here, and that's just going to be 6 times negative 2 over 2, and then plus 7. So we get 6, do the stuff in the parentheses first, negative 2 over 2, that's negative 1. So 6 times negative 1, and then plus 7. So we get negative 6 plus 7, which is going to give us positive 1, and that is the same thing that we got here. okay? So, it's the same thing. It kind of just depends on how you look at it and how you want to do it. Either way, guys, it doesn't matter which way you do it, but you do need to be able to rewrite functions, composite functions, and then also evaluate them at the same time. So, okay. Okay, let's take a look at the next question. And on this, it says that all computers are on sale for 10% off the original price, okay? If X is the original price of the computer, then the function that represents the price after only a 10% discount is what, okay? So I'm going to come in here and I'm going to create a function called P of X, okay? And P of X is the price after selling X units of computers. And what I want to do is I want to say, okay, and this is kind of tricky to do. It might seem a little bit trivial, but a lot of people get these wrong. And so if I have my original price of the computer X, okay, then I have to subtract off 10% of that original price. So I have to subtract off 10%, and that's 0.1 times X, okay? So as a result, I get this function P of X, which we're going to call 1 minus 0.1x minus 0.1x is going to give us 0.9x, okay? So really, when you think about it, you're only paying 90% when you take a 10% discount, okay? And then all of a sudden it says, all right, well, let's say that we have a coupon, okay, where it says, the function that gives the price C if only a $150 coupon is used. So if you have this other function C to represent the cost using the coupon, that would mean that you were doing X, the price, and then just minus $150 on that coupon, okay? So what I've done is I've created two functions, a function for a 10% discount and then a function for coupon. So what if you have a 10% discount followed by a $150 coupon, okay? And so what you would do then is you would, you got to think about which one are you doing first, okay? You are taking the final sale price, you take a 10% discount that is followed by a $150 coupon. So you have to read this, and it says a 10% discount is followed by a $150 coupon. So we're not applying the coupon and then taking the 10% discount. We're taking the 10% discount and then applying the coupon. And so what that means is that we have to do the 10% first, okay, and then take off the 150. So we have to use a composite function here, and it's going to be the fact that we have to do this part first. This is going to be my inside function. So what I'm going to do is I'm going to get a function, C of P of X, okay, where I actually plug in 0.9x into x of my other function, okay? So P of x is 0.9x, so we're going to do 0.9x and then minus 150, okay? And that would be our composite function, all right? Which is kind of tricky because of the way these are written, but here's that function right there, C of P of x, okay? Then it says, if a laptop originally cost $800, the balance due after a 10% discount and the $150 gift card is applied is what, okay? So what I'm going to do is I'm actually going to physically plug in $800 into this function here, into this cost function. So really what I'm going to do, and I'll just do it up here, is I'm going to do C of P of 800, okay? And I'm going to plug that in and get 0.9 times 800, take 10% of that, and then, or 90% of that, and then subtract off 150. So let's do some math here real quick. And so if I take 0.9 times 800, that's going to give me a value of 720, and then I'm going to subtract off 150, so minus 150, and that's going to give me a value of $570, okay? And that's our answer, all right, for that question. So it does have applications to it. It's not just nonsense, all right? Okay, on this one, okay, find any domain restrictions on the function f of g of x. So the domain here And let's just kind of take a look here. This is a rational function here, okay, 1 over x, and this graph looks like this, all right? No, hold on. Looks like this and like that, okay? X cannot equal 0 here, okay? The reason why is because you can't divide by 0. That's why we have a vertical asymptote at 0. So, but on this graph, this is a line. Okay, this doesn't have any domain restrictions. But if I found f of g of x, which means that I'm taking, if I rewrite this, this is really me saying, okay, I'm going to take f of x minus 4, okay, because all I'm going to do is I'm taking x minus 4 and plugging that into x in my other equation. So therefore, I get something like this. So f of x minus 4 is really just 1 over x minus 4. All right. So when I think about the domain restrictions on this, the thing that I have to think about is that I cannot divide by 0. Okay. So I'm going to take this, okay, x minus 4, and I'm going to set that equal to 0. Okay. And if I solve this equation, I've set up this equation, and I get that x is equal to 4. Okay. This is the value that makes f of x undefined. Okay? So because of that, because it makes f of x undefined, then that is my domain restriction. So my new domain, okay, my domain now on this function is all real numbers, all reals except x cannot equal 4. Okay? And that's just something that you have to look at on a rational function. Take whatever's in your denominator, set it equal to 0, solve for x, and that's the value that makes that function undefined. So then when you write your domain, all real numbers except that x cannot equal 4. All right. So let's take a look at another one, and let's see what happens here. Now on this one, on just looking at this function g of x, you've got 1 over x plus 2. Okay, the value that would make that undefined is x equals negative 2. Okay, and here's why. If I take my denominator, which is x plus 2, and set that equal to 0, we get that x is equal to negative 2. And so this is the value that makes g undefined. So g of x is undefined when x equals negative 2. Okay, and so that's my domain restriction. On this, my domain, so g of x, the domain, is all real numbers except x cannot equal negative 2. All right, so that's what's going on with g. Now, when I do a composite function here, okay, and I plug in my function h into my function g, okay, when it says g-o-h, that's really g of h of x, okay? So I'm going to take my function h, which is 3x, and plug it into x of my other function, all right? So this is really just going to give me, g of 3x, which is going to give me 1 over 3x plus 2, okay, which is what goes there. So then when I take this, 3x plus 2, and set that equal to 0 to see what my domain restriction is, I'm going to subtract by 2 on both sides, and we get that 3x is equal to negative 2, divide by 3, divide by 3, so we get that x is equal to negative 2/3, okay? Now, this is the value. This makes, okay, this makes g of h of x, okay, undefined, okay? So my domain restriction is that x cannot equal negative 2/3, okay? And that's what we've got. All right, so now let's take a look at something else here. All right, so you have this function f, another function, which is the square root of x minus 3, and then g of x is equal to x plus 5. Now, this is a square root function, okay? Let's take a look at your generic, if you just had the square root of x, the graph of that is number 0. Your domain on this is, x is greater than or equal to 0. Okay? We can only plug in positive x values into that. And so, all I know is that whatever's underneath the radical has to be positive. It has to be larger than 0, okay? So then, if I wanted to find f of g of x, then, I'm taking the x plus 5 and plugging that into x of my other function. So if I wanted to find f of g of x, is really the same thing as me saying f of x plus 5, okay? And as a result, then we're going to get the square root of x plus 5, okay, which is where I'm going to put where I put the x, and then a minus 3, okay? So then what we have is we get the square root of, okay, of just an x, and then 5 minus 3 is going to give us a positive 2, okay? So then, even though it's positive, what I still need to do is I need to take what's under my radical, okay, the x plus 2 part, and I need to make that greater than or equal to 0. So I'm going to subtract 2 from both sides, and then I get that x is greater than or equal to negative 2. Okay, and that's my new domain, all right, given that function, all right? So then, let's take a look at the next one. And so, it gives us these series of points that are on my function f, and then a series of points that are on my function g. Okay, so I don't have any functions, I just have points on those functions. So it says, what is g of f of 2? So the first thing I want to do is go, okay, well, what's f of 2? What's that? Okay, and if I plug in 2 in for my x value, I get a y value of negative 5. So I write that I have the value 2, negative 5. Now it wants me to find, well, what's g of negative 5? Okay, and if I look here, okay, I'm looking for an x value on my g function that has a value of negative 5, and that doesn't happen, okay? So because there is no value, okay, the composition is undefined, and that's it. And that's all I've got for this video. I hope you guys enjoyed it, but practice makes perfect, so make sure that you are doing the work, and if you need to refer back to these videos, then you can come back to them. So see you in a bit. Bye!